Hi, welcome to this is Park's Algebra 1 class. This is Chapter 3, Section 6, Proportional and Non-Proportional Relationships. So last section you learned about the last few you learned about direct variations that goes through 0, 0, and now we're going to learn about that are not going through 0, 0. So why are we learning this? Heather is planting flats of flowers. The table shows the number of flowers that she has planted and the amount of time she has been working in the garden. So here's a nice table here, number of flowers planted for P, and F for number of minutes working. That's T for time. So every 1, 6, 12, 18, she has 5 minutes, 30 minutes, 60 minutes, 90 minutes. The relationship between the flowers planted and the time that Heather worked in minutes can be graphed. Let P represent the number of flowers planted, and T represent the number of minutes that Heather has worked. When the order pairs are graphed, they form a linear pattern. Remember, linear means line. It has the word line in it. This pattern can be described by an equation. So here you have a nice pattern. Okay, it looks like it's going to be a straight line. So that we can write out an equation for. Okay, proportional relationships. If the relationship between the domain and range of a relation is linear, the relationship can be described by a linear equation. Linear equation really just sounds fancy. It means a line equation. Okay, so it's an equation that has a straight line, just like this. If the equation is of the form y equals kx, which we learned in direct variation, then the relationship is proportional. In a proportional relationship, the graph will pass through 0, 0. We know that part. So direct variations are proportional relationships. Okay. So this here example, it goes through 0, 0, through the origin of the graph, then it is a proportional relationship, and you describe it as y equals kx. Okay, so if you have y equals 3x, okay, every x increase, the y increases by 3, okay, and you can do rise over run. So every 3, you rise 1. So every 3, you rise 1. Okay, so here's your nice proportional direct variation. Okay, this was a review. We've learned that one. Here's another review of a proportional relationship. Okay, Marcos is a personal trainer at a gym. In addition to his salary, he receives a bonus for each client he sees. Okay, so each client he sees one client, he gets bonus pay of $45. 2 clients, 90. 3 clients, 135. 4 clients, 180. 5 clients, 225. Graph the data. So we have nice data here that we can graph the number of clients and then amount of bonuses. Okay, so notice it doesn't start with $1 going to 240. They're counting by $20 each. So 20, 40, 60, 80, 100, while number of clients you count by 1. So here's a nice graph. Okay, write an equation to describe this relationship. So when we're going to write this equation, you're going to see what the pattern is. X, the number of clients increased by 1, and the bonus pay increased by $45. Okay, so how do we write the equation? So here you have increased $45. So the equation is B equals 45C. Alright. And use this equation to predict the amount of Marcus's bonus if he sees 8 clients. So instead of C, you're going to substitute with 8. So you have $45 times 8 people, and you have $360. So Marcus will receive a bonus of $360 if he sees 8 clients. Okay. So here's your part, your turn, number 1A through 1C. So go ahead and pause the video and do those 3 problems. It's just like we did with the other previous one. If you're not sure, you can rewind or go back in the video and watch it. But here's your portion. It has a similar table. So make a graph, write the equation, and predict. And come back when you're done. Okay, welcome back. So this is the non-proportional relationship part we're going to move on to. Some linear equations can represent a non-proportional relationship. If the ratio of the value of x to the value of y is different for select order pairs that are on the line, the equation is non-proportional and it will not pass 0, 0. Okay, it's not going to go past the origin. So here's an example. So you automatically see it doesn't go past 0, 0 here. Okay, write an equation in function notation for the graph. So here you're asked to write an equation of a relationship that is graphed in function notation. Okay, find the difference between the x values and the difference between the y values. Select points from the graph and place them in a table. So here you can do 1, 2, 3, 4 as the x. And then let's find out what the y corresponding is. For 1, it's 9. Okay. For 2, it's 12. For 3, it's 15. And for 4, it is 18. Okay. And I notice there's a pattern, it's increasing by 3. Okay. But 1 over 9 does not equal 2 over 12, 3 over 15, 4 over 18. It's not proportional. Okay? So the difference between the x value is in 1, while the difference between the y value is in 3. Okay. The difference between the y value is 3. So this suggests that y equals 3x. Or the function of x is 3x plus 6. Okay, so if x is 1, then y is 1, 3 times 1, or 3. The y value for x is 1, is 9. Let's try some other values and see if we can detect a pattern. So here you have, when it's 1, it's 3. So you have 3x. Okay, so you're multiplying the x by 3. And the y is, actually, there's 6 more than each time. Okay, so that means you have your 3x, but you're going to also add your 6 to it. Okay. So the pattern is it's increasing by 3, but it didn't start by multiplying the x's. If you multiply the x by 3, you still have to add a 6 to each time. Okay, so 1 times 3, you're going to add 6 to get 9. 2 times 3, it's 6, you're going to add another 6. 3 times 3 is 9, add another 6. 4 times 3 is 12, add another 6. So here you have, your function is 3x plus 6. Okay, so here's your turn 2a and 2b. Here is your graph, your linear graph. So here's the table. So you're going to write an equation for this. Okay, so go ahead and do 2a and 2b. And this is all the homework for tonight. So you only had your turns 1 and 2. So when you're done with this, you should put this away for your homework and get credit for it tomorrow. So thanks for watching.